Hey everyone. Today I want to talk about Dalton's laws of, or Dalton's law of partial pressures. And what this law states is that the total pressure in a container is equal to the pressures of the individual gases in the container. So the total pressure in a container is equal to the sum of the pressure that each individual gas exerts on the container. For example, if I have a container and I have let's try that again. Doop, 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 doop. Okay, so I have the purple molecules and I got the yellow molecules. Doop, 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 doop. Okay, so let's say that the pressure, whoa, easy. The pressure exerted by the purple molecules is equal to 0.85 atm, and the pressure exerted by the yellow molecules is equal to 0.43 atm. Then the total pressure, let's go skinnier, there we go. Then the total pressure, P total, is going to equal P purple plus P yellow. So then the total pressure is equal to 0.85 atmospheres plus 0.43 atmospheres. Okay? So that's going to be 1.28 atmospheres. So that's Dalton's law of partial pressures. If you want to find the individual pressure, you can either use this equation, or we could say the pressure of gas X, the partial pressure exerted by gas X, is equal to the amount of moles of gas X divided by the total amount of moles times the total pressure. So this right here, nx over n total, we call that the mole fraction. So if I wanted to write this out in words, I would say that the partial pressure is equal to the mole fraction times the total pressure. So the next thing so you're going to deal with problems that aren't just adding two pressures up, obviously. So I wanted to go over sort of a tougher problem that you guys might see. And that's the case in, so let's say you have two containers, and there's a stopcock in the middle. Oh, and Christopher's favorite word, stopcock in the middle. And then there's another bulb over here, okay? And let's say the volume over here is 5 liters, and the volume over here is 0.5 liters, okay? And then let's say we have, we got a gas in here, and we got a different gas in here. Okay, now let's say a student opens the stopcock in the device above if the pressure in the large bulb before opening was 2.8 ATM and the pressure in the smaller bulb was 1.2 ATM. What are the total and partial pressures? Okay, so here's what we're going to do. This question is especially involved because there's two different things we need to do. So right now, this gas is in a 5-liter volume, okay? Just for fun, I'm going to add a couple dots over here because realistically, there would be some gas particles in the little stem part too. But it's close to this. So this whole area from here on, that's 5 liters. From here on, that's this is 0.5 liters, okay? So here's the deal. At the end, so we're going to call this one gas 1. We're going to call the red one gas 1. We're going to call the blue one gas 2, okay? So we're going to say that the pressure P1 initial, P1 was, actually, let's call it red, P red. P red was 1.2 ATM, okay? And then P blue was 2.8 ATM, okay? Here's the problem, though. If you open this stopcock, if you open the stopcock up, what's going to happen is now there's a new volume. Instead of the volume of this one being 5 and the volume of this one being 0.5, now they have a new total volume. So the partial pressures of each of these is going to change according to Boyle's law. Boyle's law says the volume varies inversely with the pressure. So if the volume increases, the partial pressure of this one, the partial pressure of both of these is going to decrease. Once we find those new partial pressures, we can add those up to find the total pressure. So what we need to do is we need to use Boyle's law to find the new partial pressures, and then we can add those up to find the total pressure. So we'll separate these into two different sections. We'll say for red over here, and we'll do the blue one over here. So for red, it says that, so we'll say P1, the initial pressure was 1.2 atmospheres, okay? V1, the initial volume, is 0.5 liters. Once we open the stopcock, V2 is 5.5 liters, okay? And P2 is our unknown. That's what we're trying to find. And P2, what P2 represents, that's our new partial pressure of the red gas. Now, it's called a partial pressure now because the gases are now mixed, okay? So I'm going to do P1V1 equals P2V2. So P2 is going to equal P1 times V1 over V2. So P2 is equal to 1.2 ATM times 0.5 ATM or liters, sorry, over 5.5 liters. And then P2, that's just going to give me hey Siri, what's 0.6 divided by 5.5? It's going to give me 0.109 ATM. Okay? Now for the blue, so this is the partial pressure of the red gas once you open the stopcock. For the blue one, our P1 is equal to 2.8 atmospheres. Right here, 2.8 atmospheres. Our V1 is 5 liters. Our V2 is 5.5 liters. And our P2 is our unknown. So for this one, because the volume didn't increase by as much, watch the pressure won't decrease as much. But P1 or P1V1 equals P2V2. So P2 is going to equal P1V1 over V2. So P2 is going to equal 2.8 ATM times 5 liters over 5.5 liters. Okay? So that's going to be 2.8 times 5 divided by 5.5 equals 2.54 ATM. Okay? Now to find the total pressure, P total. Let's use black just because that's why. P total is equal to P red plus P blue, right? And so now it's just going to equal 0.109 ATM plus 2.54 ATM. And that's going to equal 2.649 ATM. If you want to do significant digits, we would say 2.65 ATM. Okay, so that is Dalton's law of partial pressures. And have a wonderful rest of your day.